All right. So yesterday we left off, we're talking about method type 2, method C, which is visible, solvent, wash, solvent removable. All right, so we got down to developer because this is the least sensitive of the methods. What sensitivity level does it have? It doesn't have a sensitivity level.
No.
It's not given a sensitivity level, but some publications say it's close to half. Okay. Use the most sensitive developer, which is going to be form D, or the, what is it called? Non-aqueous. There we go. Okay.
Non-waterous.
There, I'll accept that. So, okay. Use just enough developer to wet the part. Use just enough developer to wet the part. Some publications say you should actually be able to see the base metal through the powder, the residue that leaves behind. So, and I've showed you in lab, you can't just kind of sit there and drench it. What'll happen if you do that, you can actually cover the crack with that stuff. And you make a mess of it for sure, and it's really hard to interpret your results. So just a very nice light fogging on there. Excessive developer can hinder the results. And we'll just jump to this, and developer time. Developer time is 10 to 120 minutes. Now, be very careful with that. As I've told you before, I don't usually walk away from this stuff. I'll watch it for the first several minutes to see what's going to happen. Now, if nothing's happening, and I've been there 5 minutes looking at it, then I can set it aside and wait the 10 to 120 minutes to come back later. Chances are you're not going to find anything. But if there is some sort of discontinuity, what's going to happen is that penetrant is going to bleed out and go quite a ways, especially if we had 120 minutes. Any hole that you didn't get in and clean out real well is also going to bleed out real bad. So it's going to make a mess. All right. Inspect. The rules are you must use adequate lighting. Use adequate. Use adequate lighting. So what kind of lighting are we going to use? Black light, white light, green light? Okay, white light. Do you remember the minimum?
100 foot candles.
Okay, we need 100 FC foot candles. What do you think a foot candle is? One candle about a foot away. So if you don't believe me, I brought in a birthday candle today, and who was in there? We lit the birthday candle, darkened the room, and we didn't make a wish yet. You got to make the wish when you blow it out. So then we held the meter. We had 0 foot candles, lit the candle. I put the meter, I didn't have a tape measure, but it was about that far apart, which is about a foot. And guess what? I had 1 foot candle. So then we blew it out and made a wish.
Yes.
You know what my wish was? That nobody would say anything stupid during lecture. I didn't get my wish.
Thank you, Steve.
I thought it was to keep your job.
I'm hesitant to use Lux because
Don't do it.
when you start going back and forth between foot candles and Lux, then you're like, wait, was it 2 or 20? So you add a 0 to get to Lux. All right, so 100 foot candles is 1,000 Lux. And of course, cracks are going to appear. Indications appear as a red line, dot, blot, blob, whatever. Okay, so if we do this and we don't find anything, or even if we do, what's next? Well, if you find something, then what do you do?
Picture.
Inspect further.
Okay, you have to evaluate it. So you get an indication, then you have to evaluate it. Is it relevant, non-relevant? Is it a proper indication, not proper indication? What are our fancy words there? Go ahead, you can go look at your notes. Definitions. What do we have?
Why don't you show them the highlighted portion?
Non-relevant indication, relevant indication.
Okay, we get an indication. Then we have to interpret the indication. We could get a false indication, which is what?
Hair.
More than likely on something like that, you're not going to get an indication from hair. I don't know. How are you developing this stuff, dude? Don't make it weird. Fingerprints. That's the number one thing. Fingerprints. Everybody who's doing liquid penetrant, what do I keep seeing when you go into the darkroom? Fingerprints. Yeah, you got fingerprint there, fingerprint there. There's an indication under your fingerprint. So that's a false indication. We could get a relevant indication or non-relevant. What's non-relevant? Yeah, something that's not rejectable. We get a relevant indication. What is that?
Indication that is caused by a condition.
Well, an indication that is caused by a condition or type of discontinuity that requires evaluation. So it still doesn't mean it's bad. So what if we got a big crack in the plate? You're not allowed any cracks, and it's a flaw. It's a flaw. Flaw or defect. Well, I'm sorry, it's a defect. Definitely a flaw to begin with. All right. Okay. Indications appear as a red line, dot, stain, however you want to put it. Are we done? Clean. You are not supposed to leave the penetrant on these parts.
Even if it's rejected?
Well, if you're going to red tag it and throw it out, then I guess it doesn't matter. But if you're going to return to service, there's any chance of it being reworked, then you have to clean it. So clean. What are we going to clean this with?
Cleaner remover.
All right, there you go, with cleaner remover, with the spot check remover, with the solvent remover. Can we use visible dye? Well, I'll just tell you. So, because we already talked about it, but Lycoming Service Instruction 1285 states do not use visible dye for these inspections, because visible. And so that's Lycoming. They're talking about liquid penetrant inspections to Lycoming engine parts. Do not use visible dye for these inspections because why?
Because you can't use fluorescent afterwards.
There you go. Because visible dye penetrant materials have an adverse, that means bad, effect on future penetrant inspections, causing indications to be tightly closed and therefore missed during future inspections. So don't do it. All right.
So even if you used visible inspection and then say the piston went in through another $2,500 cycle and it came back out, it could still...
So you just did a piston with visible dye and then you put it back in service?
Yeah, well, you're not
Can't.
supposed to.
Oh, there you go. You're not supposed to.
But would it even after say somebody did and they went...
Okay, so we had a bad mechanic who did it.
There you go. And it went the 2,500 hours, pulled apart.
Well, that's easy. I would never reuse a piston after that much time.
Okay.
But okay, to answer your question, probably after that much time, we're probably going to be talking about a decade worth of time and all that. Probably the red dye would have seeped out of the crack. But if there was a crack, I would say that probably the piston would have broke before then. Right? Because we're talking about red dye still there because there was a crack, but they returned it to service with the crack.
Mm-hmm.
It'd probably dye will work out after that much time. Be filled full of oil.
Yeah.
Yes?
But remember you said that if you can use the red dye after you've done the inspection on first with non-visible type 1.
So why would you go to red dye then?
Well, like, let's say like someone says, oh, that's a crack. You're missing it, and then you go, okay,
No.
I'll show you.
No. If I've got the facilities and I'm doing a type 1 inspection, and somebody comes along and after I've cleaned the part and says I didn't do it right, it doesn't make any sense.
Okay.
I would never go back to visible. I wouldn't use visible if I had the type 1 anyway. So, okay, let's look at another method. Just to make MJ happy. Type 1, which is what? Fluorescent. Method A, which is?
Water.
Water.
Dry powder.
No, this is a fluorescent.
Try powder?
I haven't said, it's just method A, type 1 method A. I didn't put a form in there. Form is my what?
Water washable.
What is form? All right.
Form A, B, C, D.
Oh, method A.
Can I see your book for a minute?
This one does think it's board in class. Look what, we need to sign.
I don't know what that picture is, but it looks like you dye pinned this thing. It looks like
We know what it is like.
It's a mushroom, Kevin. It's a tribal sphere.
It was the colors that I drawn.
Did you show it to the camera?
I'll edit that.
You're definitely gonna fire.
I'm gonna rewrite
All right, this is
that. Water washer.
Christian, you
All
are
right.
really in the indie team.
That's the important part.
You're really getting penetrant. It's fluorescent penetrant. That is water washable. Okay, so if it's water washable, what do you think the penetrant base is?
Water.
Okay, I would think so. The penetrant is an oil-based penetrant. Well, that seems kind of weird, but it is true. So to make the penetrant water washable, it's going to already contain an emulsifier in it. So it's oil-based with an emulsifier pre-mixed in it that makes it water washable. So to make the penetrant water washable, the penetrant contains an emulsifier. So we don't need to add an emulsifier. If I had to add an emulsifier later, then it becomes a type B or D. Gotta skip C. B, C, D. So, all right. So what are the steps? What? Okay, clean. We don't have to go into cleaning because it's the same as previously discussed, right? You can't do anything different than what we did before. You can't wire brush it, wire wheel it. You can't sandblast it, glass beat it, chisel it. None of that works. And if you do something that potentially did peen over something, then what would you have to do to it?
Acid bath.
Acid wash, yeah. Okay. Part needs to be dry between 50 to 125 degrees. So if we use, say we use a cleaner, solvent cleaner, then we have to make sure we dry out the solvent cleaner because the solvent cleaner can get into the crack and fill up the crack and the penetrant doesn't go in there. Also, you don't want to contaminate your bath because we're like our method, we have a big bath, we're going to put stuff in it. We don't want to contaminate the bath with water, then I got to buy a brand new bath and that's very expensive. All right, let me see. Then what? Clean, it's dried. We apply penetrant. Apply penetrant. What are the methods we can use to apply?
Brush.
Dig.
Applied by, what do we got?
Aerosol. Dip.
Dipping,
Brushing.
flowing,
Submerging.
spray, brush. What else do we have? Dip, which is immersion. Flowing, which is pouring. Spraying, which is a sprayer, little handheld sprayer. Brush. However you want to get it on, really. Okay, then what? All right, so if I dip it, what?
That's a dwell time.
Dwell time. Okay. If I dip it into the bath, how long do I leave it in the bath?
Take a
Long
second.
enough for it to get covered.
Long enough to get it covered, and then I
Pull it out.
pull it out. Why do I pull it out? Why not leave it in?
Surface tension.
Better surface tension when I pull it out. All right. Dwell time. Now we have dwell. How long do I let it dwell?
Depends.
Okay. It depends.
Long enough time to get covered.
Unless otherwise stated, because it may state exactly, like we did an example yesterday, and it said exactly how long, Ivan?
30 minutes.
30 minutes. Sorry, I didn't mean to wake you.
10 to 30.
10 to 120 minutes. Or 10 minutes to 2 hours. It's closely the same. Parts dipped. Parts dipped must not be left in the bath for more than 1/2 of dwell time. Parts dip must not be left in the bath for more than 1/2 of the dwell time. So if I'm going to let it dwell for 10 minutes, then I can't have it in the bath for more than,
15.
I don't know why you'd leave it in there that way, but that is the rule. And of course, dwell time does what?
Let's penetrate, seep into the cracks.
Yep. Dwell time allows penetrate to seep into the crack. Discontinuity be the better word, but I don't want to write that. All right. What would why 10 to 120? Why would I decide 10 versus 120?
Size of suspected crack.
Okay, size of the expected crack. If they're very tiny cracks, I might want longer. If they're pretty big, they would be. How about temperature?
Cold or
Cold longer.
Cold longer, hot shorter. What about your lunchtime?
Don't take it.
I mean, as long as it's not more than 120.
As long as you, there you go. All right. What comes next?
Wash.
Wash? Okay.
You wipe off the rinse.
Oops. Let's try to make this penetrant. Well, not penetrant. Let's see. Stick with what I wrote in my notes. There's a reason why I wrote that. Excess penetrant is removed. Because we don't want to remove all of it, do we? Well, we kind of do, because you hope there's no crack. But if there's any sort of discontinuity, then I don't want it all gone. So, all right. Washing is done under a black light. Under a black light. Or UVA light, so that you can see the penetrant and see how you're removing it. If you do it in white light, you're not going to see the penetrant being removed very well. You won't even see it. So chances are you're going to overwash it. Now you don't have to do it completely in the dark. I don't have it with me, but so the white light I think is you're allowed up to 20-foot candles, which is 10 times what a darkroom is, and where we normally want 1,000 microwatts per square centimeter of black light, we can drop all the way down to, I believe it's 100 microwatts per square centimeter of black light. So you don't need a lot of black light, you can have quite a bit of white light. But it is sort of darkened. Where am I here? We'll just put this. Do not overwash. And do not underwash, because that's just as bad. I'm watching you guys, you're kind of, well, first of all, some of you wear gloves, you get the gloves into the penetrant, then you have penetrant on your gloves. It wouldn't hurt you to wash your hands and your gloves first, and so that you have a little bit less on you. Then when you're holding your part, make sure that you rinse it well. I say hold it about 12 inches away from the nozzle, 45-degree spray. Spray it, and then move your hands and make sure that you're getting around where your fingers are, because that's where a lot of the penetrant is left on there. Do not overwash. Let me see. What kind of nozzle do we use?
Tricone.
Tricone. Use a tricone nozzle with a coarse spray. Max PSI at the nozzle is, anybody remember?
45.
Oh, very close, 40 PSI. With a water temp of 50 to 100 degrees. Hold nozzle 12 inches away. And spray at a 45-degree angle. Okay, now you're at a decision point. Okay, decision point. So this is the flow chart. Laser pointer. Cleaned and dried it. We applied the penetrant. We let it dwell. How long did we let it dwell?
10 minutes.
10 minutes. When we applied the penetrant, well, okay, dwell. Then we water washed it. We used what kind of nozzle?
Tricone.
Tricone. How far away do we hold the nozzle? With what's the max PSI? And the temps between? Okay. So we're right here, and I say there's a decision part. There are 3 different developers you can use. You can use a dry developer, the aqueous developer, or the non-aqueous. What does the dry developer look like? Okay, like talc powder. Okay. What is the aqueous developer? There are 2 different types.
Spray bottle.
There are 2 different types of aqueous.
Water soluble.
Water soluble is one.
Water suspendable.
Water suspendable is the other. Okay. And then we have non-aqueous, which is also there's the stuff in the aerosol can. Okay, so we get this point right here, we can decide which way we want to go. So if you want to use the aqueous developer, you're going to spray it on right now, then you're going to dry it. If you want to use a dry developer, first you have to dry it, let it dry, then put on the dry developer. If you want to use the non-aqueous, you dry it, then put that on. So the water ones are put on wet, and the dry ones are put on dry. That's not hard. So let's just say we went with the dry developer. So we dry the part. How long do we dry it? Just till it's dry. Don't let it get too hot. What's the max temp? 160. Okay. Put on the dry developer and bring it back down. And again, it's always going to say dwell. You have to wait for the developer to work, but I'm going to say that starts the inspection period right there. So I start my inspections at the same time the dwell does. If we want to use the aqueous developer, like I said, you spray it on, then let it dry. And I've said it before, I don't love the aqueous developer, and when you use it, you'll kind of get the sense why. It tends to reflect back a lot of the UV light, and it's sort of purplish. I prefer the white. And I do like the non-aqueous developer. Probably is my favorite, and it's the most sensitive. So, hey, good for me, right? All right, so that's where we're going to go with that. All right, so what do we got here? Catch up here. All right, so I said, oops, you don't need to be there. So I said decision point. Decision point on developer. Wet or dry? Do you want to go wet or dry?
Dry.
Want to go dry? How about we go wet? Then why ask? Well, I was hoping you'd say the right answer. All right, let's try wet developer first. So let's say we try wet developer. So if form B or C developer is used, the developer is applied while the part is wet. Developer time is 10 to 120 minutes. All right, so we want to use the wet developer, have B or C. B or C should be our water soluble or water suspended. If we want to use that, we use the developers applied while the part is wet. What happens after that? Okay, you're going to dry it. After it's done drying, which we're just going to wait till it's dry, then the developer time is same as before, 10 to 120 minutes, right? Thankfully, it's all kind of comes together and it sort of follows the same pattern. All right, what if we want to use dry developer? What's my dry developer? I wrote if form A or I think I went with the E on this one is used, the part is dried first. So go up one. The part is dried first.
What the formulas for type 2?
Developer, did I make a mistake there? Form E is, let me double check that.
What's that?
It's
E is for type
D. Some of them have it written as D and some of them are E.
Yeah, you said that yesterday.
So yeah, so we'll go. I'll just leave it like that. DE. Developer time is 10 to 120 minutes. Who are we talking to? You play Mario Brothers later? All right. I'm supposed to scare him. All right, and part is visually inspected. All right. Type 1 is inspected under a black light. So before we can do that, we need to check our light sources, right? Our lights. All right, so black light specs. Black light specs. So let me see. White light. Max is how much? What's the maximum white light I can have in the black light environment? 2 foot candles or 20 lux. Black light minimum is 1,000 microwatts per centimeter squared. That's the minimum, not the maximum.
Is there a maximum?
Not that I'm aware of. Actually, you know what? I think I did read something somewhere that talked about a maximum because it's just too much, too overpowering. But I don't have data on that one. And typically that's 15 inches from the light. 15 inches from the light. Now you have to, of course, consider the fact that if I put my light up here and I'm doing work here, is that adequate?
No.
Because I'm measuring the light intensity at 15 inches, but yet I'm working 45 inches away. That's not okay. So the proper way, and you just want to make sure that you have at least 1,000 microwatts per square centimeter at your inspection site. So the standard, I'd say, would be to hold the measurement 15 inches away, but at the same time, when I do the inspection, I'm going to keep the light 15 inches away from my source, from what I'm inspecting. So I'm going to bring the light down to where I'm working. So my light's always about 15 inches away from when I'm working, or closer.
Can you have multiple lights?
Can you have
Like, could you have like 2 of those LED?
Sure.
Okay.
Yeah, I've seen them where the entire room is just a black light. They'll just, instead of this type of light, they'll add, I don't want to say fluorescent, but in the ceiling. So you turn off the white light, turn it on, the entire room is a black light. I've been in a room like that before. I don't know if I would enjoy that. I like the intensity of the light right in front of me looking out, but that's just kind of the way I like it.
You probably need goggles when you go back to white light.
I know you should wear UV screened goggles actually in this environment. All right, and then okay, can I move over? Janet, what are you doing way back there?
Where's Janet? She here?
Yes, I thought she wasn't too, and I saw her hiding back there.
Silly.
Were you back there yesterday too?
No.
No. I miss you right there. Now I got nobody sitting right here. Tim's gone. You're gone.
You served it for your
Do I spit when I talk? Is that what's going on? Who's moving up?
Alright, yeah, to the east side.
Hey, now I don't have a clear view of the screen.
Now you do have a clear view?
Oh,
Now I don't have.
I watched that screen.
Oh, that's
Nice
interesting.
up here.
Isn't it? It's like a luxury seat, huh?
Yeah, this is like first class.
You know what? It's and it is. It's like a luxury seat.
Yeah, throw cookies
You
out.
get, yeah, you get cookies up here. Yeah. Guy comes around, offers you cookies. Yeah, you want a drink or something too?
I'll take a foot massage. I'll take a rum and coke.
He'll share his vodka with you.
Yeah. Kristen's got some drawings you can look at. Well, come up here.
That's what fun is.
All right.
What's that drawing, Christian?
But we're not going to tell Tim he's sitting there, right? Because that's Tim's chair.
Oh,
So, okay. Where am I? Okay, now we have, so we're still under inspecting the part. Went through the white light, black light, indications. Indications must be interpreted.
Those parts we were looking at yesterday for your friend, didn't it say right in the paperwork that you had to use a magnifying glass to inspect? Or
It said it's helpful.
Oh,
Must be interpreted. So we could have true or false. This isn't a question. It's just don't yell out true, Christian. True.
false.
I did tell him not to yell out true. Indications. So true or false indications. True indication is if true, is it A, non-relevant, or relevant? If relevant, is it a flaw, which is non-rejected, or B, a defect, rejected? And then we want to, I'll make that one X. How's that sound?
You were way off.
Was I? That's way out here. What do you want it to be? Part?
You're on 7.
Not yet. Part is thoroughly. Thoroughly cleaned. Penetrant and developer. Penetrant and developer. I'm going to throw this in here because it's really important. Anti-corrosion is applied as needed. And I like LPS3 as a corrosion preventative. So LPS3. So are you familiar with LPS 123 products? So I'll actually make that so it's.
Is that just anti-corrosion, like you put it on there and then put it in a bag or something to keep it?
LPS 3. Okay, so LPS 1 is like a very lightweight oil. Similar to WD-40, I'll say. All right, so it's kind of a greaseless. It leaves, doesn't leave a film, so it doesn't collect dust. So I like LPS 1 for hinges on airplanes and stuff like that. Bearings and pulleys and such. Doesn't want to collect and keep the dirt on it. LPS 2 is a little more heavy duty. Maybe if I have to loosen a bolt or something that's rusted, corroded, go in LPS 2. LPS 3 is not a lubricant, which is kind of funny because last year or so I saw somebody brought in a control cable for like a throttle that had been sitting frozen forever and it was stuck and they couldn't move it. So they had a can of LPS 3 and they're spraying it in there trying to make it work and get it frozen up. Well, LPS 3 is wax. So when you'll see when we put LPS like on a crankshaft, I coat it pretty heavily. You go to pick it up and it's just this wax nasty coating. It's like it's not slippery or anything. Your hands stick to it, right? So it's like that's not a lubricant. So if you're doing non-ferrous parts, they're not going to rust and they usually don't corrode. So you don't have to worry about it. But think about the stuff you're doing for an engine. If you're doing crankcases or cylinders, they're partly steel. Crankcase has metal studs in it, exposed metal parts. So put a little corrosion preventer on it because it's been through a water wash, it's been through the penetrant, it's been through another water wash, then it probably was washed again to get rid of the dye. So it's had a lot of water treatment to it. So give it some rust prevention. Dry it and give it some of that. If I was working on crankshafts, especially crankshafts and cylinder barrels, they're often nitrided. Crankshafts are, excuse me, and usually the inside of cylinders are. They'll rust right away. Like our hot seat machine, you take a crankshaft or those cylinders. If we were to put them in the hot seat machine, like at the beginning of lab, and the machine was already hot, come back 2 hours later, you got rust on your hands. It's gonna look terrible. You're gonna go, dang, how long was this stuff in here? So an hour or two, it'll rust pretty well. So you got to get it out right away and apply corrosion prevention. Yes, I would stick it. I would soak my stuff in LPS 3. I went through so much of this stuff. I probably went through a case every other week, maybe.
When I got my block back from the machine shop before I painted it, they had like put oil all over it and then bagged it.
Yeah.
It took me like 2 days to clean it to get it ready for
Yeah, paint doesn't stick.
No,
So
horrible.
it is, but I don't paint crankshafts. So hey, there you go.
Inside engine has to look just as good as the outside.
It does, but it's polished. It's shiny. So anyway, yeah, I would coat stuff. Crankshafts, I would wrap them up in Trade-A-Plane. I always wrap stuff in Trade-A-Plane. I don't know why. I've had so many of them, like newspaper, and put them in a bag. So, all right, let's see. We'll take a break there.